Good morning, this is Kavipriya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic subtractor. And this is my flow of presentation. I am going to give a introduction about combinational circuit and I am going to explain about the subtractor, the types of subtractor, half subtractor and full subtractor. So first, what is a combinational circuit? A combinational circuit is one in which output at any instant depends only on the present input. So it doesn't contain any memory element. So adder, subtractor, multiplexer, demultiplexer, encoder, decoder, everything comes under the combinational circuit. So this is a classification of a combinational circuit. Combinational circuit in turn classified into arithmetic and logic function, transmission and code converters. So the combinational circuits classification is broadly done based on the three functionalities. So under arithmetic and logic function, adders, subtractor, comparators and PLDs comes under that. Under data transmission, we have mux, demux, encoder and decoder. Under code converter, we have binary, BCD and 7-segment code converters. So what is a subtractor? So subtractor is a combinational circuit which takes binary bits as an input and it performs a subtraction operation on the binary inputs and it produces an output. It produces two outputs, which is nothing but it is a borrow and difference. So we have two types of subtractor. They are half subtractor and full subtractor. The basic difference between a half and the full subtractor is nothing but the way in which it handles the input bits, where half subtractor takes only two binary bits as an input and it produces two outputs, which is nothing but it is a difference and borrow, whereas full subtractor operates on three binary bits A, B and C in. So these subtractors is a fundamental component as like adders in arithmetic and logical units, in microprocessors and so on. So first, half subtractor, and this is a block diagram for half subtractor. It takes a two inputs and it produces the outputs difference and borrow. And this is a truth table for the half subtractor. We have only two inputs. So totally we'll be having four combinations starting from 0, 0 to 1, 1. So we have two outputs, which is nothing but difference and borrow, which is represented as D and B naught here. D will be 1 when input combinations are 0, 1 and 1, 0. And borrow will be 1 when input combination is 0, 1. Based on these output values, we can map the values using this K map and we can get the Boolean expressions. So after simplifying this truth table values using this K map, we'll be getting a Boolean expression for borrow and difference. So the Boolean expression for borrow is A bar B plus A B bar, which is nothing but A XOR B, and for borrow it is A bar B. So using the Boolean expressions, we can draw the logical diagram. For difference, it is A XOR B, and for it is borrow, it is A dash B. So A and B is given as an input to the XOR gate. In output, we'll be getting as a difference, and for borrow, we'll be giving a to an inventor, and the output will be A dash. So which is given as a input to the AND gate, along with B, we'll be getting the borrow. And next is the advantages, drawbacks and applications of a half subtractor. Half subtractor is very simple in construction and it is ease of implementation. It is a basic building block for full subtractor. Drawback is that it is limited to two inputs. It can't handle this carry input and it is restricted to the applications. And applications of this half subtractor are, it can be used in the electronic calculator for performing the arithmetic operations, and it can be used in the arithmetic and logical units. And next is an activity which is a puzzle, which is nothing but unscramble the letters to find a word, which is very much related to the digital electronics. The first one is a logic gate, and second one is a binary, third one is a transistor, fourth one is a buffer, and final one is a sequential. All these words are related to digital electronics. And next is a full subtractor. Full subtractor is one which takes a 3 bits as an input, which is nothing but A, B and B in here over here, and it produces the output which is nothing but difference and borrows. And this is a truth table for full subtractor. We have 3 bits as inputs and we have an output as difference and borrows. So difference will be 1 when input combinations are 001, 010, 100 and 111. And borrow will be 1 when the input combinations are 001, 010, 011 and finally 111. And later K-map is used for simplifying to get the simplified expression for difference and borrow, and the simplified expressions for difference is a dash b in plus a b dash b in bar plus a b b in plus a dash b b in bar. Whereas for borrow it is b b in a dash b plus a dash b in. And next is nothing but it is a logical diagram for this full subtractor. For difference, after applying this further simplification techniques, we'll be getting a Boolean expression as A XOR B XOR B in. Both the three inputs will be given as an input to the XOR gate and we'll be getting an output as a difference. For borrow, you'll be using 3 AND gates and output of the AND gate is given to the OR gate. And what are all the advantages, drawbacks and applications of this full subtractor? Advantage is that it can handle it is a multi-bit subtraction. It can handle the 3 bits simultaneously. It is of high speed. Its efficiency is higher when compared to the half subtractor. Drawback is that the complexity is increased when compared to the half subtractor and power consumption is high when compared to the half subtractor, and also there is some propagation delay. Applications are it is used in arithmetic and logical units. It is used for processing and for memory addressing and so on. And this is an assessment question, and half subtractor performs a subtraction of 2 bits whereas full subtractor performs a subtraction operation on 3 bits. The output equation for difference in case of full subtractor is nothing but A XOR B XOR B in. To implement a full subtractor using half subtractor, you require only 2 half subtractor and an OR gate. So that's all about the subtractor. We have discussed about the basics of combinational circuit and we have discussed in depth about the subtractor. We have discussed about the half subtractor and what are the advantages, drawbacks and applications, and about the full subtractor. Again the logical diagrams, truth table, and finally about the advantages, drawbacks and applications. Thank you.